Hello everyone, hope you all are doing well. So today we are going to do the next topic of our geography series. जो हमारी geography series चल रही है उसके next topic को आज हम लोग करने वाले हैं. And today we are going to discuss about global atmospheric pressure belts and jet streams. तो आज हम लोग ग्लोबल एटमॉस्फेरिक प्रेशर बेल्ट्स और जेट स्ट्रीम्स इन दोनों को डिस्कस करने वाले हैं. तो फर्स्ट ऑफ ऑल वी विल डिस्कस अबाउट ग्लोबल एटमॉस्फेरिक प्रेशर बेल्ट्स एंड व्हाट आई मस्ट से यू दैट प्लीज डू मेक नोट्स. मैं हर वीडियो में आप सबको बोलता हूँ कि प्लीज डू मेक नोट्स, कीप मेकिंग नोट्स बिकॉज रिमेम्बरिंग these amount of facts and concepts by seeing videos will not be easy. So please do make notes and keep revising your notes. By revising your notes, all the things will be struck in your brain, and whenever you see options in the exams you will be easily able to do the answers. Okay, so चलिए देखते हैं global atmospheric pressure belts. So let's start. So first of all we will discuss about corallospores. And in this year's prelims corallospore से question भी आया था, so it is important. So you see that corallospore is always anti-clockwise in north hemisphere, anti-clockwise in north hemisphere and clockwise in south hemisphere, clockwise in south hemisphere. It increases latitudinally, increases, that is when there is increase of latitude from equator to from equator towards poles, there is also increase in corallospores. So you can write here that it is maximum at poles, it is maximum, and it is minimum at equator, or you can say zero at equator, minimum at equator, and on the equator it is zero. Okay, and it increases altitudinally also, increases altitudinally also. That is, increase of altitudes also leads to the increase of corallospore. So you can say that at surface it is minimum, and below troposphere it is maximum. Below troposphere, below troposphere, or you can say, so not below troposphere, below tropopause it's maximum. How can it be below troposphere? Below tropopause it is maximum, just below tropopause. And when corallospore is maximum, when corallospore is maximum, it forms a resultant wind. It forms a resultant wind, and these winds are only known as geostropic winds. Geostropic winds. An example of this geostropic wind is none other than jet winds, or we say jet streams. And these jet winds or jet streams also you can be able to see it below tropopause. Below tropopause. So these was about corallospores, the most important points about corallospores, and you should remember these because it have been asked in the UPSC several times, and these are basic concepts which you should know. Now, now let's see the pressure belts and different cells. So for that, let me make a earth first of all. So this is our earth, and what you will see, there are different pressure belts. Here we have equator, and at the equator what you will find, equatorial low pressure belt, equatorial low pressure belt. And as we move northwards and southwards from equator, you will find subtropical high pressure belt. This is subtropical high pressure belt. Again similar in the southern hemisphere also, subtropical high pressure belt. As you go over subtropical high pressure belt, you will find subpolar low pressure belt. Subpolar low pressure belt, and again as you go down you will find subpolar low pressure belt. Okay, subpolar low pressure. Then again when you go up you will find polar high pressure. It is polar high pressure. Similarly here also you will find polar high pressure. So these are the pressure belts located on the earth. You can see it is equator, it is 0 degrees Celsius, and as you can move up you know, and it is poles, and here you will, this line is 66 and a half degree. Here it is 66 and half degree Celsius. Okay, so you all know this. So this is our earth, and now there are certain cells which work at this belts. First of all, before doing this, let me show you the tropopause. This is the, let this be the tropopause. This is tropopause. Just to showcase you, okay, on over the earth you are seeing this layer as tropopause, and here at this place you will find forming, the winds are going up, and you will see the forming of a cell. The winds are first going up, then deviating, and then going lower. So this is known as Hadley cell. Hadley cell. Let's see again, same here, going up, then and coming lower. So this is Hadley cell, and this Hadley cell is found between equatorial low pressure and subtropical high pressure. Secondly, the winds has come down here. Again, here you will see the winds going up. Sorry, here the winds going up, and again coming down here. So this is feral cell between subtropical high pressure belt and subpolar low pressure belt. Again, you can see this is feral cell, and then here you will find polar cell. Polar cells, the wind going up and then coming down here. These are polar cell. Same here, wind coming up, going up, and coming down here. These are polar cells. You will find that the trade winds, okay, generally they will jet streams, then generally you will find jet streams between the two cells. I'm mentioning here jet streams located between two cells. Between two cells. Jet streams are generally located between two cells. Now we will see the movement of westerlies, or you can say movement of winds. Orange. So you will see here that suppose this is our here here westerlies are found. So generally you will see the movement of these winds like this. Here first, and here they will move in the feral cell. They will move towards poles, and in the Hadley cell they will move towards the equator. Okay, like this. So what you will find that here westerlies are moving towards poles here. These are the geostropic winds. These are the westerlies which are moving towards poles. And Hadley cells they are moving towards equator. So these are trade winds. Trade winds when divergence towards equator. When divergence towards equator. And this phenomenon happens in the both sides of the equator. Okay, in the northern hemisphere also, in the southern hemisphere also. Now what you should see, the movement of winds. Now, as you can see in lower in between subtropical high pressure belt and equatorial low pressure belt, you will see trade winds. So as you see in Hadley cells, trade winds are moving towards equator. So these are like this. These are trade winds. Trade winds. And as they are coming from northeastern direction, they are known as northeastern trade winds. Similarly, you will find in southern hemisphere also. These are southeastern trade winds. As we have also discussed in the uh, monsoon season, these southeastern trade winds only wind comes into the influence of Coriolis force, they divert into this direction and comes to in Indian monsoon as north southeastern sorry southwestern winds. Okay, because due to the Coriolis force, they gets diverted over the equator towards the south, towards this direction, towards the northeast direction, and there seems to that they are coming towards southwest, and that is why in Indian monsoons are said to be coming from southwestern winds. So I hope you understand this. If you want to clear this concept in detail, you can refer the Indian climate video. Okay, so I hope you understand. And again, between subtropical high pressure belt and subpolar high pressure belt, you will find westerlies. So these are westerlies because they are coming from the west direction. These are westerlies. And again, between subpolar low pressure belt and polar high pressure belt, you will find easterlies, that is coming from east direction. These are easterlies. So these are easterlies. So this was all about the are just some of the winds and pressure belts. Okay, I hope you understand this. These are the cells also here: polar cell, Ferrel cell, Hartley cell. You should remember these cells. And all these together, as they are three cells, this is known as tricellular meridian model because there are three cells working together. Because three cells, Hartley cells and Ferrel cells and polar cells are working together. Tricellular meridional model. That is three cells in each hemisphere. Three cells in each hemisphere. And these easterlies, which you are seeing here, this region, these easterlies dissipates in fronts and cyclones. That is why you will see that formation of lot amount of fronts and cyclones in temperate regions. Easterlies dissipates in fronts and cyclones. Fronts and cyclones. So these were the pressure belts and sails. I hope you understand this. Now we will move towards jet streams. Okay, jet streams. So this is important. Draw it clearly in a big sheet of paper and keep things in mind. Keep the concepts in mind where the winds are diverting, how Coriolis force is acting, how the winds, the geostropic winds are moving towards poles and moving towards equator. The trade winds moving towards equator. Westerlies moving towards poles. So all these concepts are simple concepts which must be remembered. Okay. Now we will move to jet streams. Jet streams. So jet streams are nothing but they are only a type of geostropic winds only. Geostropic winds, also known as upper air westerlies, also called upper air westerlies. That is, they always blow from west to east direction, and they flows and in upper air westerlies because they flow just below the tropopause in the upper layers of troposphere. Flow just below tropopause. and this is important, and this point is also important. Keep in mind that because they always flow from west to east direction. Okay, keep it in mind. Engine for the movement of jet stream is temperature contrast. Engine for the movement of jet streams is temperature contrast. Temperature contrast between two adjacent cells. Between two adjacent cell. That is why thermal gradient in engine for movement of jet stream. That is why thermal gradient is the engine for movement of jet stream. Thermal gradient, the temperature contrast is used by jet stream as the engine for movement. Gradient is engine for of jet streams. Of jet streams, you can see that between the two cells, you can see between the two cells there is thermal contrast, or you can say thermal gradient, temperature gradient, in which jet stream uses for its engine of movement. That is why you will find jet streams between two cells. Hope you understand this. Now jet streams are of two types. First one is the polar jet stream. Polar jet stream, which is can be seen between polar and ferrule cell. Between polar and ferrule cell. So you can see this is the polar jet stream between polar and ferrule cell. This one. And secondly, we have subtropical jet stream. Between ferrule and Hadley cells. Between ferrule and Hadley cells. You can see also here between this ferrule and Hadley cells, here this region, this can be ferrule and Hadley cells. You will, this is subtropical jet stream, and this between polar and ferrule cell you will find polar jet stream. So I hope you understand this. So you can draw a simple globe also, simple earth also showing this. The upper below layers, here you will see polar jet stream. Here you will see subtropical jet stream, and the thing is similar for southern hemisphere. Also here you will see subtropical jet stream, and here you will see polar jet stream, and the jet stream is always moving from west to east. Keep it in mind. So let's see how jet stream is formed. This is the gradient force, PGF, polar gradient force, and this is the Coriolis force. So the resultant wind of this gradient force, polar gradient force and Coriolis force, is nothing but geostropic wind. The resultant wind, it is, you can see Coriolis force is below the tropopause. So its resultant wind, one is going up, one is coming down, and the resultant wind is nothing but, you can see, jet stream. This is the resultant wind, and these are only known as geostropic winds. Jet stream is the example of this geostropic wind only. So you know why they are named jet stream. There is an important story behind it if you want to know. So why they are named jet stream? Because as they were flowing at very high speeds. Okay. See, I am just giving you just an example through a map. This is USA. Okay. Okay, let it be. Not go in that much detail. So as they are flowing in very high speeds, these jet streams already in very high speeds. So these winds were used by the jet planes to move into these layers, because what happens due to the high speed of jet streams, the wind, the speed of the jet planes increased to a significant amount. That is why jet planes use this area only, so that they move in high speeds. That is why these are known as jet streams. So I hope you understand the story behind its naming. Now, now we will discuss jet streams and weather conditions. Jet streams and weather condition. First one is subtropical jet stream. How it is linked to some weather condition? It is linked with ITCZ and hence influences monsoon. Linked with ITCZ, intertropical convergence zone, and hence influences monsoon. We all know that how ITCZ influences monsoon, especially on India. Now, what is the role of polar jet stream into weather conditions? So, these polar jet streams has critical role in the genesis of temperate cyclone. Critical role in the genesis of temperate cyclone. Next, when jet streams forms a crest at the top, jet streams forms crest at top, then there is low pressure at surface. Low pressure at surface, we have discussed in previous videos also. And when there is trough on the top, there is high pressure at surface. So what happens when there is trough? This is trough. So there will be high pressure at the surface, trough, and then there is crest. Crest. This is crest. There will be low pressure at the surface. So this is important. So these are how this is how jet streams are related with weather conditions. So this was all for today's video. I hope you understand about all the geostrophic winds, pressure belts, cells, jet streams. So please do like, or please do press the like button if you like it. Please do share, and please do subscribe. It takes a lot of hard work to make such videos for you on regular basis. Regular basis पे से videos को बनाने के लिए काफी hard work लगता है. And if you like, if you share, if you subscribe, it motivates us to make more such videos for you regularly. So that is all for today. Have a nice day. Thank you.